Hi, in this video, we will discuss about trigonometric identities. Trigonometric identities are trigonometric equations that are true for every value of the variable involved. Now, if we consider the right angle triangle and our angle is inclined at vertex A, and we have that the side opposite to the angle is known as the opposite side. So side small letter a is known as the opposite side. Also, the side adjacent to the angle is known as the adjacent side. So the side small letter b is known as the adjacent side. And the longest side of the right angle triangle, or the side opposite to the right angle, which is angle 90 degrees, is known as the hypotenuse side. So having defined our opposite, adjacent, and hypotenuse side, we can be able to derive our trigonometric ratios. So we know that sine theta is equal to opposite divided by hypotenuse. From the figure, our opposite side is A and our hypotenuse side is C. Also, cos theta is giving us adjacent divided by hypotenuse. From our figure, our adjacent side is given as B and our hypotenuse side is given as C. Also, tan theta is given as opposite divided by adjacent. And from our figure, our opposite side is given as A and our adjacent side is given as B. Also, it can be shown that tan theta is equal to sine theta divided by cos theta. Now, from our trigonometric ratio, sine theta is given as A divided by C, or divided by cos theta is given as B divided by C. Mathematically, this can also be expressed as A divided by C divided by B divided by C. At this point, if we apply our multiplicative inverse, our equation becomes A divided by C multiplied by C divided by B. So C can cancel out C. We'll be left with A divided by B. So it has been shown that tan theta is equal to sine theta divided by cos theta. Also, we can establish that cosec theta is equal to 1 divided by sine theta, which will be equal to hypotenuse divided by opposite. From the figure, our hypotenuse side is given as C and our opposite side is given as A. Sec theta is given as 1 divided by cos theta, which can also be expressed as hypotenuse divided by adjacent. From our figure, our hypotenuse side is given as C and our adjacent side is given as B. And cot theta can be expressed as 1 divided by tan theta, which can also be expressed as adjacent divided by opposite. And from the figure, our adjacent side is given as B and our opposite side is given as A. Hence, we can also establish that cot theta is equal to cosec theta divided by sec theta. Cosec theta is given as C divided by A, and sec theta is given as C divided by B. This can also be expressed as C divided by A divided by C divided by B. If we apply the multiplicative inverse, our equation becomes C divided by A multiplied by B divided by C. So C can cancel out C. We will be left with B divided by A. So therefore, it has been shown that cot theta is equal to cosec theta divided by sec theta. Now, let us consider the Pythagoras Theorem. The Pythagoras Theorem states that the sum of the squares of the opposite and adjacent side of a right-angled triangle is equal to the square of the hypotenuse side. Mathematically, the theorem can be expressed as AB all squared is equal to BC all squared plus AC all squared. And from our figure, AB is represented as C, that is C squared, equal to our BC is A, which is now A squared, plus our AC is B, which is now B squared. Now, from here, we can name this equation 1. Now, let us divide equation 1 by C squared to obtain other trigonometric identities. So, divide equation 1 by C squared. Our equation becomes C squared divided by 6 squared equal to A squared divided by C squared plus B squared divided by C squared. So from our left hand side, C squared divided by C squared is equal to 1, equal to, here becomes A divided by C all squared plus B divided by C all squared. From our ratios, A divided by C is sine theta and B divided by C is cos theta. So therefore, our equation becomes 1 equal to sine squared theta plus cos squared theta. So therefore, sine squared theta plus cos squared theta is equal to 1. Now, again for my equation 1, now let's divide equation 1 by A squared. We will obtain that C squared will be divided by A squared equal to A squared divided by A squared plus B squared divided by A squared. Our equation becomes C divided by A all squared equal to A squared divided by A squared is given as 1 plus B divided by A all squared. Now from our ratio, we obtain that C divided by A is equal to cosec theta and B divided by A is equal to cot theta. So our equation becomes cosec squared theta is equal to 1 plus cot squared theta. Also, if we divide equation 1 by B squared, we obtain that C squared divided by B squared is equal to a squared divided by b squared plus b squared divided by b squared. Now, from our left hand side, we can express our equation as c divided by b all squared equal to a divided by b all squared plus b squared divided by b squared is equal to 1. From our ratios, we obtain that c divided by b is equal to sec theta and a divided by b is equal to tan theta. Therefore, our equation can now be expressed as sec squared theta is equal to tan squared theta plus 1. Thus, from Pythagoras theorem, we were able to obtain that sine squared theta plus cos squared theta is equal to 1. Sec squared theta is equal to tan squared theta plus 1. Cosec squared theta is equal to 1 plus cot squared theta. Let me call here equation A, call here equation B, and call here equation C. But from equation A, we have that sine squared theta plus cos squared theta is equal to 1. Now, if we move cos squared theta to the right hand side, our equation becomes sine squared theta is equal to 1 minus cos squared theta. Now, to obtain sin theta, we take the root of both sides. So our equation becomes sine theta is equal to root of 1 minus cos squared theta. Let me call here equation D. Also, sine squared theta plus cos squared theta is equal to 1. Cos squared theta is equal to 1 minus sine squared theta. To obtain cos theta, we take the square root of both sides. The equation becomes cos theta equal to root of 1 minus sine squared theta. Call here equation E. But tan theta is equal to sine theta divided by cos theta. We have established that sine theta is equal to root of 1 minus cos squared theta divided by cos theta. Also, sine theta divided by cos theta can be expressed as sine theta divided by root of 1 minus sine squared theta. Call here equation F and call here equation G. Now, having obtained all these trigonometric identities, let us use them to solve some examples. Example 1 says that show that tan squared theta minus sine squared theta is equal to sine to the power of 4 theta sec squared theta. Now, we have to consider the terms in the left hand side. So we know that from our left hand side, tan squared theta is equal to sine square theta divided by cos square theta. Now, if we substitute tan square theta into the equation, we obtain that sine square theta divided by cos square theta minus sine squared theta is equal to sine to the power of 4 theta sec squared theta. So the left hand side can be expressed as sine square theta multiplied by 1 divided by cos square theta minus sine square theta equal to sine to the power of 4 theta sec square theta. But we know that 1 divided by cos square theta is equal to sec squared theta. So therefore our equation becomes sine square theta multiplied by sec square theta minus sine square theta is equal to sine to the power of 4 theta sec square theta. From our left hand side, we can factorize, we can have that sine square theta open bracket sec square theta minus 1 is equal to sine to the power of 4 theta sec squared theta. But tan square theta is equal to sec square theta minus 1. So therefore our equation becomes sine square theta times tan square theta equal to sine to the power of 4 theta sec squared theta. So therefore our left hand side is now simplified as sine square theta multiplied by sine square theta divided by cos square theta, which is equal to sine to the power of 4 theta sec square theta. So from here we can establish that sine square theta times sine square theta is equal to sine to the power of 4 theta divided by cos square theta equal to sine to the power of 4 theta sec square theta. Now our left hand side can be expressed as sine to the power of 4 theta multiplied by 1 divided by cos square theta is equal to sine to the power of 4 theta sec square theta. 1 divided by cos square theta is given as sec square theta. So therefore our equation has shown that sine to the power of 4 theta sec square theta is equal to sine to the power of 4 theta sec square theta. So it has been shown that tan square theta minus sine square theta is equal to sine to the power of 4 theta multiplied by sec square theta. Example 2 says, show that sec square theta minus 1 divided by sec square theta is equal to sine square theta. First, we know that sec square theta is equal to tan square theta plus 1. So therefore, in our left hand side, our numerator becomes tan square theta plus 1 minus 1 divided by sec square theta equal to sine square theta. Now plus 1 minus 1 we cancel out. So we are left with tan square theta divided by sec square theta, which is equal to sine square theta. The left-hand side of our equation can now be expressed as tan square theta multiplied by 1 divided by sec square theta equal to sine square theta. But 1 divided by sec square theta is equal to cos theta. Therefore, we obtain that tan square theta times cos square theta is equal to sine square theta. Our left-hand side can further be expressed as sine square theta divided by cos square theta multiplied by cos square theta equal to sine square theta. Now, from here, sine can cancel out sine. Our equation shows that sine square theta is equal to sine square theta. Let us consider example 3. Example 3 says, simplify 1 minus cos square theta divided by sec square theta minus 1 all in square root. We established that 1 minus cos square theta is equal to sine square theta, and also sec square theta minus 1 is equal to tan square theta. Therefore, our expression reduces to sine square theta divided by tan square theta. This can also be expressed as sine theta divided by tan theta all squared so square cancel out square root. We are left with sine theta divided by tan theta. Now our equation can now be expressed as sine theta multiplied by 1 divided by tan theta. This can be given as sine theta times cos theta divided by sine theta. So sine cancel out sine. This is giving us cos theta. So therefore, that is the answer.